Yes guys, welcome back to our new video. So now we want to look on the types of DC machines. So for the types of DC machines, we have they are broadly classified into two. We have the self-excited DC machine, and the separately excited DC machines. But under self-excited DC machines, we have a subgroup of shunt wound DC machine and a series wound DC machine, and the last group under the self-excited is the compound wound DC machine. So it can be like this: DC machines can make it this way, then classify them as separately excited and the self-excited. So under self-excited, we have the series wound DC machine, then we have a compound, but before the compound we have the shunt wound DC machine, and the last one under self-excited we have the compound wound DC machines. So we'll be looking at the diagram. Let's take a diagram of each of them here, because under shunt we have the long shunt and the short shunt, but we'll bring in the details more. So under separately excited, here the field windings or the coils are excited or energized from a DC source, which is separate from a separate DC source. So this is the diagram. This is the field windings and this is the DC source. So the DC source energizes the field winding, which in turn uses the load, the armature windings there, which has the load. I think it's clear here. This is the diagram. Then the other one is the self-excited. So for the self-excited, there are those whose the field magnet or windings are energized by a current produced by the machines themselves. So they are not, the windings are energized within the machine itself. That's why it is called self-excited. Then you can say, as you can see here, there are three types of self-excited DC machines. As I have said earlier, we have the shunt wound DC machines, the series wound DC machine, and the compound wound DC machine. Let's look at the shunt wound. Shunt is like connecting things in parallel. Like we have the coil, then you have the armature here, then you have the load. You have here positive and negative. Then you have the windings, the field windings. So for the shunt, as you can see here, the field windings are connected across or in parallel with the armature conductor, and hence and have the full voltage of the machine. Since anything which are connected in parallel, the voltage across here will be the voltage across here and the voltage across the load, since they are in parallel. So this is the circuit diagram, or the equivalence. It's the diagram of the shunt wound DC machines. We have the shunt here, the shunt field windings, which are the coils. Then we have the armature here, from which we have the armature current which is flowing up. This is the current which is going to the load. Then you should know the arrow, how the arrows are pointing. So this is the field current, field winding current. So this is the diagram here. You can write short notes. Then the second one, under the self-excited, we have the series. Then for the series wound, the field coils are connected in series with the armature conductor. So if two conductors are connected, if two components are connected in series, meaning they collect the same current. So the second statement says the series field gets the full armature current. The full armature current, they get the full armature. For the other one, they were getting the full voltage, but for this one, they're getting the full armature current, and they consist of the relatively few turns. They consist of the relatively few turns of thick wire to reduce the reluctance or the resistance. So this is the diagram for a series wound. We have the armature here, then we have the field winding, and we have the load. They are connected in series. Then the last part is the compound wound. A compound, as the name suggests, is just a combination of the two, of the series and the shunt. So the combination of the two. So for the short, the compound, they are further classified into two. We have the short shunt compound wound and the long shunt compound wound. Short shunt, the connection is like this. The shunt field is connected in parallel with only the armature. Connected in parallel only in the armature. And we have the series, another series winding here. So another shunt winding which is connected in series, in parallel with the armature. Then you have the load. So this is the field current, and this is the current which goes to the load, and this is the armature current. That's what it's called short. Yeah, so that's all about the short shunt. Then for the long shunt, in this connection, the shunt field is connected in parallel with both the armature and the series field. So the shunt field is here, and we have the series field windings, and we have the armature here. So we have the armature is connected with the series field windings, and then both of them are connected in parallel. So you have the field windings current, then you have the armature current here, then you have the current which goes to the load. So this is the long shunt, and this here is the short shunt. So thank you guys, see you next time. Don't forget to subscribe and hit the notification button. Thank you, bye bye.